Okay, so the lesson we're doing today is 4.5, Computing with Scientific Notation. So we're going to look at multiplying, dividing, adding, and subtracting. So we'll start out example 1. Says scientists estimate that there are over 3.5 times 10 to the 6 ants per acre in the Amazon rainforest. If the Amazon rainforest covers approximately 1 billion acres, find the total number of ants and write it in scientific notation. So they went ahead and showed us, okay, well, 1 billion is 1 times 10 to the 9th power. So here's our problem, right? Let me do that right here. 3.5 times 10 to the 6th times 1 times 10 to the 9th. So what we do, since we are multiplying, so we really have this times this times this times this. Since it's all being multiplied, we can rewrite it, putting these front two numbers together in parentheses, and then putting our times 10 to an exponent together in parentheses. So it becomes 3.5 times 1 times 10 to the 6th power times 10 to the 9th power. Once we get it here, now we can solve. 3.5 times 1 is 3.5. Then when we have 10 to the 6th power times 10 to the 9th power, we talked about last week, when you're multiplying with the same base, you just add your exponents. 9 plus 6 is 15. They show that right here. So here is your final answer. The only thing you have to watch out for is make sure your decimal is in the right place. You might end up having to add a place value to get it in the right place. So what I want you to do now, looking at that problem, you can rewind it and rewatch that if you need to. I want you to attempt 1A and 1B on your own. Pause it, write those down, try it, and then I will go over them with you. All right, example 1, we have 4.62 times 10 to the 5th power times, when they're side by side, 8.15 times 10 to the 9th power. Since these are being multiplied and they're both in scientific notation, times 10 to an exponent, what we can do is we can rewrite it. I can put these front numbers together, and then I can put my times 10 to an exponent together. So what that would look like is I will have 4.62 times 8.15 in parentheses, since it's this times this times this times this. So I have these, and then I still have times. We have 10 to the 5th times 10 to the 9th. Now we can solve. We can just multiply these two. Let me grab my calculator. Then, as we just did last week, when we have exponents that are being 10 to an exponent that's being multiplied, you add the exponents. 9 plus 5 is 14. Now, we are not done, because if we know scientific notation, the decimal always needs to be behind the first non-zero number. So I've got to move it one more time. Since that went from 37 to 3.7, it got smaller. That was taking a place value away. Or actually, no, we added one. I'm sorry. 15. Okay, example B. Same thing, we're multiplying and they're both times 10 to an exponent, so I'm going to rewrite it, putting those two front numbers together, and then my exponents together. So when I multiply this, 7.53 times 2.93, and then over here I have negative 8 plus negative 3, negative 11. Now, that means it's a very small number. So when I go this way, you're actually taking one away. Because if it's negative, that means the decimal's really way up there. Okay? So you're technically still adding one, because negative 10 plus 1 would be negative 11 plus 1 would be negative 10. Sorry, it's early for me. All right, let's look at example 2. Okay, so we just looked at example 3. Now we're going to look at, I don't know why that's doing that, sorry. Now we're going to look at example 2. So we just multiplied, now we're going to look at dividing. So the first example says evaluate 7.56 times 10 to the 8th power over, which means divide, 3.15 times 10 to the third power. So when it's written like this, it makes it very simple because they're both times 10 to an exponent. So we can just divide these front two numbers. And when we're dividing with 10 to the same number to exponents, you subtract your exponents. So they rewrote it here to show you. It's the same thing as having this. So we can divide 7.56 divided by 3.15. That gives us 2.4. When we have this, that means you do the top minus the bottom. 8 minus 3 is 5. So our final answer becomes 2.4 times 10 to the fifth power. So I want you to try 2A and 2B so you can see that. Don't forget those negatives on using that. Use your calculator to check your work, and then I will go over those with you. On example 2A, we have 4.62 times 10 to the fifth divided by 1.4 times 10 to the negative 9. Since they are both times 10 to an exponent, we can go ahead and divide these front two numbers. So I have 4.62 divided by 1.4, and I get 3.3 times 10, and then if you remember when we had 10 with an exponent being divided, you subtract your exponents. So I have 5 minus negative 9. Two negatives become a positive. 5 plus 9 is 14. So 3.3 times 10 to the 14th power. On 2B, same thing. They're being divided. They're both times 10 to an exponent. So I'm going to divide these first two numbers. I have 2.5627 divided by 5.23 comes out to 0.49 times 10, and we're going to subtract. I have negative 9 minus negative 3. Well, that becomes plus. So it's negative 9 plus 3, which is negative 6. That means this is a very small number. Now, that's not a non-zero number. I want the decimal right here. Since it's negative, that means it's really a small number, okay? And I moved it that way, so I'm just moving it one more, so that would become negative 7. 4.9 times 10 to the negative 7th power. Okay, I think we're going to move on to example 4 from here. Okay, so now looking at example 4, we're going to do two of them together, A and B. I want you to write both of these down with me because these are a lot more difficult than the multiplying and dividing because they have two added extra steps. So right here, we have 5.45 times 10 to the third power plus 3.12 times 10 to the fourth power. Now, since we are adding, these times 10s to an exponent have to be the same exponent. So what you should do is always take the bigger exponent, change it to the smaller one. So 4 to 3 means we would have to change it 1. So that just means we're going to take away one place value. So if you notice that decimal in the red over here went from right here to behind the 1. They took one place value away, which changes that 4 to a 3. Now that they're both times 10 to the third power, right here, we can rewrite it, and now we can add these front two numbers. So I have 5.45 plus 31.2. Since they are the same exponent, we just are going to have times 10 to the third power now. Just like when you're adding fractions, your denominator does not change. It just stays the same. So when we add those, we get 36.65 times 10 to the third power. But right here, I want everybody to look at this because that is not in scientific notation yet. Scientific notation, your decimal is always behind the first non-zero number. So we have to take that decimal and add a place value now to move it right here. So that means this 3 will become a 4 because we are adding a place value. So most of the time, when you have to change one of them, you're going to end up having to change it back at the end for your final simplified answer. So it comes out to 3.665 times 10 to the fourth power. If you still are kind of catching up, pause the video so you can finish writing that down because we're going to go ahead and look at B, and I want you to write this one down also. Okay, so on B, we have 2.78 times 10 to the fifth power minus 46,500. Okay, right off the bat, if you notice, this one's not in scientific notation yet. So on this line right here, they put it in scientific notation. You would move it 1, 2, 3, 4 times to get your decimal right there. So 4.65 times 10 to the fourth power. Now we have times 10 to the fifth power times 10 to the fourth power. We can't do that yet till those are the same. So we're going to change this 5 to a 4. So 5 to 4 is 1 time. You can move it more than once sometimes. It might be like 13 and 7, and you would have to move it enough times to get them both to 7. So that means we are going to take a place value away. Since that's a positive exponent, that means this is really a large number. So to take one away, you would make it look bigger. So 27.8 times 10 to the 4th power minus this. So now that they are both times 10 to the 4th power, we can rewrite it and subtract. So I'm going to have 27.8 minus 4.65, and then we just have times 10 to the 4th power out here. Using your calculator, when you subtract that, you get 23.15 times 10 to the 4th power, but that is not simplified yet. That decimal needs to be behind the 2, so we're going to go back and add a place value. So it's going to be 2.315 times 10, since we added one place value, to the 5th power. Okay, I know this is not so simple, but I want you to pause the video and try 4A and 4C. Then I'll go over them with you. Okay, so like I just said, adding and subtracting tend to be more difficult than multiplying or dividing, because when we're adding with numbers in scientific notation, okay, we have to have the same exponent. So they're both times 10, but here I have 7 and here I have 5. We cannot add these front numbers until those exponents are the same. So what you want to do 9 times out of 10, almost always, you're going to just take the bigger exponent and change it to the smaller one. So that means we have 7 and 5, so we're going to make them both 5, which means I don't have to mess with this one, just this first one. So since it's a positive exponent, that means that's really a big number, okay? So if I'm going to take 2 places away, I'm just going to undo 2 of them. So there's a 7, I have 1 empty spot, which means I would add a 0. So my decimal is now here, times 10 to the 5th. Now if you look at that, that's not in correct scientific notation, okay? That's not simplified, but we can do that to solve the problem and then simplify our final answer. So I now have this plus 6.25 times 10 to the 5th. Now that they are both times 10 to the 5th, I can rewrite it adding those front 2 numbers. And it's going to be times 10 to the 5th. Since these are the same and it's adding, you don't do anything with them, you just keep that the same. Just like, kind of like when you're adding fractions, you keep your denominator the same. So now I can just add these 2 numbers. That's 176.25 times 10 to the 5th, and then 9 times out of 10, when you had to change one of them, you're going to have to end up changing your final answer back, because we want our decimal right here. It's a positive, so I added 2 more place values to that. So it's 1.7625 times 10 to the 7th. If you notice, it went back to what we started with. That's your final answer. Okay, on 4C, same type of problem, but now we are subtracting. So again, they have to have the same exponent. I have 11 and 9. So we're going to change this 11 to a 9. So that's 10, 9, 2 places. So I'm undoing 2 place values. So I have 284. Your decimal's here, but you don't have to put it for that. It's now times 10 to the 9th power minus the other one. So now, since they're both times 10 to the 9th, I can subtract these front 2 numbers. I'm going to rewrite it so you see what I'm talking about. And then we have times 10 to the 9th. So I have 284 minus 5.4. I get 278.6 times 10 to the 9th. We are not done because that's not in correct scientific notation. Your decimal should always be behind the first non-zero number. So I've got to go back and add 2 place values. So 2.786 times 10 now to the 11th power. If you kind of notice a pattern, most of the time it's going to start out with 1 and go back to it at the end. All right, so now we will discuss what we're going to do in class.